Assalamualaikum and very good morning. First, let me introduce myself. My name is Muhammad Fareq bin Ibrahim. I'm from Universiti Teknikal Malaysia, and today I will present about our first chapter of connecting things, which is some professional training provided by Cisco. First chapter, we will cover about chapter 1, things and connection. What is things? What is connection? Then at the end of this chapter, you are able to understand first, what is things, analyze the things that make up the IoT, which is Internet of Things. Second, connection, it will explain how things are connected to other things and the IoT. Third, we will do some summarize on this chapter. Let's start. What is things? We start to understand details about things, we start with Internet of Things. The term IoT, which is most famous terms nowadays. IoT is now all around us. You can have it from your smartphone, from your internet, from website, and so on. IoT will help individuals to improve their quality of life. IoT also help industry to become more efficient. Why? Because now in industry, when you have all the internet, we can monitor or communicate to the others by using the internet. All at the end of your fingers. Next, what is Cisco IoT solution? The rapid of IoT growth has introduced a new challenge. Cisco IoT system reduce the complexities of digitization. And then in this Cisco IoT must consist of 6 pillars, which is first, network connectivity, how the network connection, fog computing, about the database and the cloud system, cybersecurity and physical security, which is one of the most important things in the IoT, about the cybersecurity, the secure, the saving of your data and so on. Next, data analytics, how they analyze the data. Management and automation, which once you have the IoT system, all must be automated. And then, last but not least, application of enablement platform. All of this will cover at the end of this 4 days training. Building blocks of an IoT system. When we'll talk about the IoT system, it must have a control system. Control system, we have one of it, feedback loops, which are used to provide the real-time information to the controller based on the current behavior. In the closed loops, feedback is continuously being received by the controller from sensor. For the closed loop, it will receive by the sensor. The controller continuously analyze and process information, and it will use actuators to modify condition. What it is, I will cover detail after few slides. Next, sensor. Inside the control system, it must have a sensor. What is sensor? Sensor is a device that can be used to measure a physical property by detect some type of information from the physical world. Sensor may be connected to a controller either direct or remote. Direct means you directly connected. Remote means you can use wireless connectivity. Actuators. Inside the control system, it must consist of actuators, which is basic motor that can be used to control a system. It can be hydraulic, it can be electric or pneumatic. Can be responsible for transforming electrical signal into physical output. So actuators, something like you can consider as output, and then inside it has hydraulic output, electric or pneumatic. Hydraulic represent the fluid, electric is electricity, pneumatic is air. Next, controller. What is controller? Controller is responsible to collect data from sensors and provide the network connectivity. Controllers may have the ability to make immediate decision. It may also send data to remote and more powerful computer to analysis. So what is controller? Controller get the data from the sensor, and then they provide the data to the network connectivity, and then the data will be analyzed for the powerful computer, more powerful computer. And then controller must have ability to make immediate decision once they get the input from the sensor, directly control the actuators. In the IoT process flow, simple IoTs must consist of sensor for connecting, either through wireless or wired, and then the connection in between to the actuators or controller. Some devices can have more than one function, means there's some sensor that can also act as controller. Some of actuators that's connected, embedded inside the controller, so it might have that function. In control system, all right. In control system, they must have process. Process is a series of steps or actions taken to achieve a desired result by the consumer to the process. Feedback. What is feedback? Feedback is when the output of the process affect the input, mean the output will affect the input. Feedback is often referred to the feedback loops. Feedback loop can be positive and negative. What is this? We will go detail after this. Inside the control system, it must include a controller that use inputs and outputs to manage and regulate the behavior of the system in an attempt to achieve a desired state. The control portion of the system, often called the plant. Choosing the adjustment to apply a plant to achieve a desired output is called control theory. Control theory applied in many systems, including driving a car. Driving a car itself is control system. You monitor, you control the speed, you control the acceleration, you control the steering. This is all the control process. Now we go to the open loop and closed loop control system. Open loop control system doesn't have a feedback. The plant performs a predetermined action without any verification of desired result. Open loop control system are often used in simple processes. While closed loop control system is a little bit complex. Closed loop control system use feedback to determine whether the collected output is the desired output. The result of the feedback into control system to adjust the plant for the next iteration output, and the process repeats. All right. So this is closed loop and control system. The simple example that easy to understand is HVAC system. This is HVAC system. HVAC is air conditioner at your house. All right. When you buy an aircon, there's one option in your remote to set either you can control the fan speed, right? The fan speed you can control either level 1 to 3, or you can set auto. Auto means you are in the closed loop control system. While when you set directly 1 or 2 or 3 level, so this is we call open loop control system. What the difference? When you set auto, you can see, let's say you set 25, means you set desired temperature is 25 degrees Celsius. And then the thermostat will hit cooling down the thermostat of the aircon blower, and then the HVAC plant will blow the fan, the air, and then the output. Let's say you are in the open loop control system, means there's no feedback here. Open loop, no feedback. Let's say now the temperature is 23 degrees Celsius. Even though you set 25, but the small room, the temperature may down up to 23. But the fans still go to the level that you set. Let's say you set the highest level fan, level 3, it keep below level 3. And the temperature might reduce less than 25 degrees Celsius. This is open loop. While when we talk about the closed loop system, they have one feedback, thermometer to measure the output. Thermometer we consider as the sensor to measure the output. Let's say, again, you set 25 degrees Celsius. The HVAC process, the fan flow is the same, but now the temperature is 23, which is less than we expect, 25. How you know 23? Because the thermometer will measure the 23, the output result. So thermometer will give feedback, mention that now the temperature is 25. Therefore, the HVAC system will manipulate it to reduce the fan. Instead of using the highest fan speed, it reduced to maybe level 1 or level 2, so that the temperature not become cooler. This is first, you can reduce the electricity lah when you use this kind of the closed loop feedback. So this is basic example of the open loop and closed loop system. All of it are system. So in these cases, our sensor come from thermometer, while the actuators come from the fan blow. So you know the fan blow, the control speed of the fan come from the electricity. Maybe some relays to control on and off, and then high power, low power, and so on. And then the controller inside, it have either maybe microcontroller or microprocessor. We don't know inside the HVAC system. All right. Process in control system. Inside the control system, they consist of three uh, controllers, which is P, PI, and PID. Come from PID. P represent proportional, I represent integral, D represent derivative. All of it have their different option, which is we cover detail after this. Arduino and Raspberry Pi is the devices that can be used to implement PID controllers. All right. Interdependent system. Most systems are many interdependent pieces contribute effect output. So this is interdependent. Means this one, the climate issue, the temperature rise, will melt the iceberg and so on. So this is we cannot control the system. So this is again is a system, but interdependent. It's not depend to the hour. You cannot control it. All right. So let's cover basic control system. What is connection? Before we start about connection, we will take 5-minute breaks, and then you may ask any question if you have to ask about what is controller and basic introduction. Thank you.